Hey guys, this is Academic Chemistry, Chapter 3, Section 3, and today we're going to be talking about converting problems with the metric system, so going between different prefixes. So the first thing I want to bring up is I have these two measurements, and they're exactly the same. So I could say 3 million centimeters or 30 kilometers, and that means the same thing. Now this brings up why we use the metric system and why we have these prefixes. It's really inconvenient to list all those zeros for 30 centimeters when you could easily say 30 kilometers. So 3 million is this giant number. It's easier to use a small, add the prefix and just have a small number. So let's just analyze what's big and what's small in what we're looking at. So centimeters is a really small unit. This is relative, so I mean compared to like a picometer, it's not, but compared to a kilometer, a centimeter is really small. Remember I said in the last video, the centimeter is about the width of an average adult pinky. A kilometer is like half a mile, so the kilometer is the bigger one, centimeter is smaller. But 3 million is a big number, versus 30 is the smaller number. So when I compare just these two measurements, if I just look at the numbers, 3 million is way bigger than the number 30, but that's because a kilometer is way bigger than a centimeter. So you always have if you're comparing two things, see this is a big number with a small unit is equal to a small number with a big unit. Now there has to be certain differences. It's not just any large number and any small number. There are certain ways to analyze them, and we're going to go over that today. So let's analyze this looking at the prefixes. So centi, as you know, is 10 to the negative 2. So centimeters is a meter divided into 100 pieces. A kilometer is 1,000 meters, or 10 to the third meters. So the difference between these two is a factor of 10 to the fifth. So if I have a centimeter, I need 10 to the fifth of those to make a kilometer. And if you notice, 10 to the fifth is going to be 100,000. And these are different by 100,000. So 30 times 100,000 is 3 million. Or 3 million divided by 100,000 is 30. Remember, the kilometer breaks into smaller, lots more smaller pieces, which might be centimeters, or centimeters can build up to be one thing of a larger unit. Now, this is kind of a funny little number line that we don't usually see, because if you notice it's actually smaller over here. Generally, you would get bigger to the right, and you'll see why in a minute why I don't use it in the normal order, because 10 to the negative 12, negative would generally be on the left, but for here, we're going to show it on the right. So these are your small units to the right. So pico is the smallest one that we might use in class. Tera is over here on the left. I don't generally list that, but it's good to point out, like gigabytes, terabytes, you've probably heard of those on your computer. Those are part of the metric system. We're going to use this number line to convert between prefixes or remove or add prefixes just by moving the decimal based on this number line. So here's that number line again. And here are your rules. If you are changing a prefix to go more to the right, so say you're going from mega to kilo, or mega to no unit, or mega to deci, mega to centi. So anywhere that goes that way. So if you're going to the right, then you're making your measurement into something with a smaller unit. And you know if you have a smaller unit, you then need to make the number bigger. To make the number bigger, you're going to move the decimal to the right. And that's why this is listed with the small units on the right, so that you remember that you move the decimal whichever direction you go. Okay, if you're going the other way, if you're going to the left, that means you're giving a larger unit in the end. So say you're going from micro over to giga. There are a lot of micros in a small amount of gigas because micros are small, gigas are big. So you don't need very many of the big thing. You need less of them. So when you're going to the left on this prefix number line, then you have to have a smaller number, so you move the decimal to the left. So let's do some problems. All right, how many picograms are in 4.3 micrograms? So the first thing you want to do is find all this on your chart. So here's micrograms, that's where you're starting, and you're going to picograms. So you're going over to the right. And that means you're going to move your decimal to the right as well. So let's write our number, 4.3, and I'm going to move it however many times the difference between these is. So the difference, and that's absolute value, so don't worry about negatives, just what is the difference between this 6 and 12 is 6. So I'm going to move my decimal 6 spots to the right. 1, 2, 3, 4, 5, 6. All right, now here's a pretty sweet animation for you. And then fill in the rest with zeros. All right, this looks great, but you know I want my answers in scientific notation, and you need a unit. So it's going to end up being 4.3 times 10 to the 6th picograms. If you notice, we did 10 to the 6th over, and we want it positive because we need big numbers. So it was a difference of 6. That's because each time you move here, you need 10 more of them, because it's actually, the unit is a tenth smaller, so you need 10 more things. So you need times 10, times 10, times 10, times 10, times 10, times 10, or times 10 6 times. So since this is just a 1 through 10 number, so this number is less than 10, I can just easily add that 10 to the 6th, or 10 spots to the right. Let's do another one. How many kilometers are in 7.8 times 10 to the 2nd centimeters? So the first thing is to find your units. So we're going from centimeters to kilometers, so we're going to the left. And we've got a rule here. So when you're moving to a bigger prefix, you're going to subtract the difference from the exponent. So how many over do you move here? 1, 2, 3, 4, 5. And when you're moving to the left, those are your bigger units. So you need to get a smaller exponent because you don't have as many of the big things to make up for a lot of the small things. So let's write our number. And since we moved to the left 5, I'm going to actually take away 5. Okay, so 7.8 times 10 to the negative 3 power now. And I have negative 3 because I had 10 to the 2nd, but when I go to the left, I need to make everything smaller, so I subtract the exponent. Don't forget your unit. That's the really important thing to have the final right answer. So this is to get to the kilo prefix, and we're measuring length or meters, so kilometers. Let's do another one. How many liters are in 4.01 times 10 to the negative 5th megaliters? And megaliters, that's a lot of liters. It's a lot of fluid you have there. So we're going from mega to no prefix, and that's going to be called your base unit. So that's 10 to the 0. It's 1, right? You don't have any other prefix on it, but you can still do that. So you can still go from base unit out of base units, add prefixes, or you can take away prefixes in this system. So we're going from mega to the base unit. So the difference is 1, 2, 3, 4, 5, 6. Now we are getting to be something smaller. So mega is 10 to the 6th. So that's 1 million. And you're getting to just 1. So this is smaller, so you need your number to be bigger, because with a small unit gets a bigger number. So the rule is when moving to a smaller prefix, add the difference to the exponent. So we said this was a difference of 6. So we have our number here, and then we actually add 6 to the exponent because this is 1 million times of the smaller unit. So I need 1 million times larger in my number, or 10 to the 6th larger. So I have negative 5 plus 6 in my exponent. That will give me 1 up there. So 4.01 times 10 to the 1st. And you always, 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 always have a unit at the end. So this is just liters. So make sure you don't have any naked numbers, right? You can't just like put a number and whatever. Everybody has to dress it up with some units so you know what the heck you're measuring. All right, here are 3 problems that I want you to work out on your own. So go ahead and freeze the computer, press pause. I'm going to put the answers up, see how you do. If you get them, great. And if not, go back and rewatch some other examples and see if you can figure them out. Okay, good luck.